this section is hard is traditionally students don't like fractions, and traditionally they don't like factoring either. And this section combines, guess what? Both of those at the same time. So that's why this one can be challenging. I've got 3 different types of problems right here. I'm going to add a 4th because it's a little heavier. We'll just take it step by step. And if you're good at fractions, you're probably going to say, what's the big deal, Mrs. Yates? And a lot of people in this class are better at fractions than I've had in the past. So you do have that on your side. So let's see where we go. To add and subtract fractions, what do you have to have? You have to have a common denominator. And then they give me things like this, right? And so it's not as obvious to see what that common denominator is. So we're going to go and we're going to look at the 6 and the 22 first. What do 6 and 22 both go into? What's their least common multiple? Not their factor, but a multiple, something that they would divide into. 66. I think 66 is right. And then we go and we look at the variables. And you always take the biggest one. That's the secret. So I look at x, and I say no x or x squared. Which one's bigger? X squared. All right, y or y squared. What's bigger? So if that helps you, let's write a little note here. Always biggest variable. And then I need to come back and I need to figure out what I need to multiply these by to make it match my common denominator that I just found. So what do I need to multiply this by to make it look like this? 6 times what is 66? I need an 11 and an x squared and a y. Is that okay? Now if I multiply the bottom, I also have to multiply the top. And let's look at our other side. What do we need to multiply this second fraction by? X squared, y squared. Okay, so I need the 3. Now that we have that, let's multiply. 11x squared y times 5x squared would be 55, x to the 4th y plus 21. Now, something I notice here is that sometimes students want to go back and they say, oh, okay, these y's will cancel. Can you do that? You can't. You can only cancel out a y if it was in all of our terms. Here, here, and here. So don't be tempted to reduce where you can't. If you have a question, if you can reduce, just let me know. We'll figure it out together. How do you feel about that one? Not so bad? That is the answer. We just added those 2 fractions together. Isn't it beautiful? Okay. How is problem 2 different than problem 1? I've got subtraction on the bottom, don't I? So I have a binomial here. Up here we had monomials. So the secret when we've got polynomials, binomials in this case, is you're going to want to factor them. So is their greatest common factor here? 3. All right, so let's factor it. 3 and x minus 5. I draw a line through that because I don't even want to think about it anymore. I want to look at it in its factored form. Greatest common factor on the right. 6. X minus 5. Now that we have those in factored form, I'm going to look at it, and I'm going to determine my common denominator. What do 3 and 6 both go into? 6, right? 6. So 6. So take care of the 3 and the 6. And the x minus 5, they both share it, so I just need an x minus 5. I'm going to change colors here. What do I need to multiply the first fraction by to make it have my common denominator? 2, right? If I multiply the bottom, I need to multiply the top. What do I need to multiply my second fraction by to make it match my denominator? Nothing, it already matches, right? Now you guys notice when I was talking, I snuck some parentheses in right there. They're helpful. You want to look at those as units. So keep them together. And now I'm just going to distribute here. I've got, let's see, 2x plus 20. Something that gets lost, especially on our subtraction ones, is that guy right there. I'm subtracting the second fraction. And people ask me, every time we do this, does the minus go to the top and the bottom? I want you to think about that. If I had a negative over a negative, what does that make? A positive. So it can only go to one place. So traditionally, we take it to the numerator. So as I write this down, I've got a minus 3x and a minus 15. Those parentheses around that second fraction numerator kind of help my eyeball see that that negative needed to be distributed through there. So that's part of the reason I like to do that. Like terms, what do we have? 6x minus 5. 2x minus 3x is negative x. And then I have plus 5. Now this is where it gets mean. You type that in, and it's wrong. Can anybody see why? Yeah. I think I heard what I wanted to hear. Are these just opposite of each other? Right? If their signs were opposite of each other, well, if I could make these the opposite signs, they would be the same factor and I could cancel it, right? So what if I were to factor out a negative right here? What would happen? It'd make it a positive x and a negative 5 over my 6 times x minus 5. We went to here. Now what happens? Cancel, cancel, and we're left with what? Negative what? 1/6. Good. So that had sneaky little things in there that makes it a very challenging problem. When you look at them one at a time, not so bad, but when they're all in there together, there's room for error. Questions on that one? Okay. What do you see here? Does it make you nervous looking at this problem, or are we okay? Well, yeah, that's what I see too. I see, all right, so we're going to look at the top by itself. We're going to look at the bottom by itself, and then we'll end up doing that division problem. Okay, so if I look at the top, what would my common denominator be? I need the x and I need the y. So what do I need to multiply that first fraction by? Y. In fact, I'm just going to put it right there and right there because there's no need to distribute. What do I need to multiply that second fraction by? X. X. And so I get what? Y plus x. Can I put x plus y? Is that going to make anybody cry? What if there had been a minus there? Could I have done that? No. Okay, now let's look at our bottom fraction. This is 3 over 1. So what would my common denominator be there? X and 1 both go into x. So my first fraction is fine. What do I need to multiply the second fraction by? X. Combine my numerators there, and I have 1 minus 3x. How you feeling so far? I'm seeing a lot of this. I've got a fraction divided by a fraction. What do we do? Skip, flip, and multiply? I love that you guys say that. Who taught you that? What teacher was it?
Mrs. Coleman.
Mrs. Coleman? Skip, flip, and multiply? Anyone else? Yeah? All right, so I'm going to have my x, my 1 minus 3x, right? We're just going to divide. What do you see there? What's going to cancel? X, x. Let's multiply straight across. So I have my x plus y times 1. That was convenient. Over, let's see, y times 1 minus 3x. Leave in factored form. Trust me. Don't multiply that out. Later when we graph something like this, now you guys are already seeing the foreshadowing there. Like what? We're going to graph these. Later when we graph something similar to this, it won't have two variables, but we'll want it in factored form. Okay. Questions on that problem? All right, now let's get really serious. Write that one down on the back. I've got polynomials in the denominator, so what are we going to do? Going to factor. You're still writing, so I'll hold up for a second. Okay, greatest common factor on the left-hand side. 6. And some of us are still getting stuck on factoring something like this. So I'm going to take time, I'm going to go slow. I'm going to go through that. Is there a greatest common factor? Okay, so let's factor out the greatest common factor. That'll make my life a little bit easier. Now, because this 2 is here, I can't just do a factoring shortcut, right? I need to do that rainbow method. I need to find two numbers that when I multiply them, 2 times 3 is 6, and when I add them, they're -7. What are my two numbers? -1, -6, -6, -1. Does the order matter? No. So I'll go -1, -6, since that's what I heard first. I'm not going to forget about this 2, so I've got to bring it down. So I've got 2x squared minus 1x minus 6x plus 3. Remember, we rewrite that middle term. Now we're going to split that down the middle. Greatest common factor on the left-hand side. Good. Can't forget about this 2. So I've got x times 2x minus 1. Greatest common factor on the right-hand side. 3. And because this guy is negative, I'm going to choose to factor out a -3. 2x minus 1. I know I've done this right and it factors because those match. I've still got this 2 I've been bringing down. But now I've got 2x minus 1, our greatest common factor there, and our x minus 3. Now, because that's an absolute disaster, and I want to be able to see what I'm doing here in a second, you guys can choose to rewrite or don't. It's not going to hurt my feelings. But I would like this in one place while we're talking about it together so we can see it easily without having a whole bunch of stuff in the way. Okay, we've already been working for, what, 5 minutes? And we're not even done with the problem yet. Question, Cambry?
So on that 2, how do we how do we know the 2 goes with the x minus 3? Or does it not go with the other, like, I don't know how to describe it.
This outside 2?
Yeah.
So another thing I could have and maybe should have done is put brackets all the way down. That was our original greatest common factor. So I was bringing it down all the way.
Yeah.
And so it's just still there.
Okay, so it does still go with everything. It's
Mhm.
just,
It's still 2 times. We ended up factoring that, and that's what we got. Did I answer your question? That didn't feel very clear. I'm sorry. Lots of work, and we're still not there. Remember, we are subtracting these 2 fractions, so I need a common denominator, right? So what would my common denominator be? 2 and 6 both go into 6. So that's done. They share an x minus 3. There's my x minus 3. And I also need the 2x minus 1. What do I need to multiply this first fraction by to make it match? 2x minus 1. Top and bottom. What do I need to multiply this bottom fraction to make it match? I have a 2 already. I want it to be 6. I need to multiply it by 3. Now, I'm going to choose to put that 3 in front because my brain likes to distribute that way. So you can put it wherever it makes sense to you. Now that we've got that, let's distribute. Am I going slow enough for your notes? Okay. 10x minus 5. What are we not going to forget on this next half? All right. So negative 3 times x is negative 3x plus 3. So let's combine, and I've got 7x minus 2, x minus 3, 2x minus 1. You should always double check. Can I factor that numerator? I can't. But you should check, factor it if you can, to see if you've got common factors. Now, your assignment today is lengthy because it's this stuff. Don't rush, scream through it. If we need more time tomorrow, we'll take more time tomorrow. That's fine. Let's just see how far we get.